Hello and welcome to Algebra Classwork 324 Guide. So I'm sitting here making a video to help you guys. So the first section was interpret graphs of quadratics in context. So here is a beautiful quadratic. It's a parabola. Violet throws a ball up in the air. The graph below shows the height of the ball in feet after t seconds. How many seconds have gone by when the ball is at its highest? So the highest is going to be the very top of this, which is 0.75 comma 9, and it wants to know the height. It wants to know the seconds though. If you look on the side, height is on the y-axis, time in seconds is on the x-axis. So we need the x value. So for this one, since it wants amount of seconds, it's 0.75 seconds. Hit submit and hit yes. So it's all about reading on this one. So on this one, same type of idea. When is the rocket at its greatest height? Well, its greatest height is once again the vertex, the very top. But this time we want height, which is the y-coordinate, which is going to be 5,476. So 5,476, enter, enter. And let's do another one for good measure. A tennis ball is dropped from a certain height. The graph below shows its height in h after t seconds. What is the ball's initial height? So the initial height is when the ball is going to start, which is at 0 seconds, which is at a total feet of 69.12 inches. So I'm just going to type in 69.12. And that's it. So that was interpret graphs of quadratics in context. Next is interpret graphs in context using graphing technology. So this is one where we're going to open up another tab and go to Desmos and open up their graphing calculator. So there is an equation here. I can just highlight, copy, go on my graphing calculator and paste it. It did not paste out very well. So what I'm going to do is I'm going to try to rewrite this equation. So instead of h of t, I'm going to put y equals negative 16 x to the second power plus 80 x plus 96. And then I can scroll and I can look. This is my graph. And it makes a parabola. It's very, very wide. And it wants to know what is the rocket's greatest height. So now this one, I have to kind of think on this one. So this is the greatest height all the way up here at this point, which is at 2.5 comma 196. Let me see if I can make this slightly bigger. So this is the greatest. Now I got to stop and think for a moment. Just like the last ones, the height is the first number, or sorry, the height is the second number. It's our y-axis. So in this case, it's 196. So let's type in 196, enter, and we did it. So this is just one we get to do. Now, this one says, what is an appropriate domain? Domain means that the x-axis. So this one's going to be a little bit harder. So I'm going to do the same thing. It's negative 16t squared this time plus 112. So I'm going to change that to 112 plus 60. 60. So domain is the x value. Now on this computer program, if you don't know how to fully work everything, it's going to be hard. However, we could do some interesting things. I'm going to go up here and I'm going to say, well, my x-axis looks like garbage. Let's set it at negative 10 all the way up to 100. Nope, 100 is not big enough because we go up even higher. So let's do 150. Nope. 200. Nope. 300. Notice how I'm just doing the guessing and checking over and over and over again. So now I can see all the graph at once. It wants us to know the domain. So what is the smallest to the x that it can go? Well, if you actually look at this, this can go all over the place. But we have to remember, this is talking about t represents seconds. So what is the least amount of seconds anything could be? Well, that's going to be 0 seconds. Then, because we're talking about domain, it's going to be the less than x less than sign. And then we can go back. Well, what is the furthest? Well, if y is our height, that means this is the furthest that we can go, because anything after this one point right here would be into the ground, and we know a ball can't travel into the ground, so that's 7.5. 7.5. Now the only problem is if I look at these three down here, we need to add in some type of bracket system. A parentheses would mean the ball is never at that spot, and a bracket would mean that the ball can be at that spot. Now since, oopsie, I hit the wrong button. It won't let me do it. Ah! Okay, so I just got to retype that way. So they want 0 and they want 7.5. Like that. There we go. Let's hit submit. Hit yes. And that's all it took. So this is something kind of new. This is set notation. We have not talked about it too much, but you just need to remember the regular parentheses means it can't be that number, where the brackets means it can be that number. And just remember, this is, it says graphing tech. That means you are allowed to use Desmos. Now, next up is Parabola Features. So here we go again. This time, let me switch over to my iPad for a second. So we have axis asymmetry is our first one. Now we need to remember that's x equals negative b over 2a. So on this problem, since it's asking us to determine the axis of symmetry, that means it's going to be an equation where we have x equals, and axis of symmetry is where could you split it in half? Well, I can clearly see that negative 3 on the x. It would be right here. Unfortunately, my mouse doesn't show up that well. But at negative 3, oopsie, negative 3 is where this parabola can be folded in half. Hit yes, and there we go. And it even says cuts the parabola in half. Now, next, the y-intercept. Well, y-intercept is a point. And it's always 0 comma something. So you can already get started like, oh, this is going to be 1 point. It's always 0 comma something. It's wherever the blue line hits the y-axis, which is right here at negative 8. So tab negative 8. Submit. Yes. And there we go. And the only other one, let me see if I can get to it, is x-intercepts. X-intercepts can be a little bit of a challenge because there is always either no solutions, i.e. it will never hit the x-axis. One solution, the vertex is actually on the x-axis. And the last one is 2 x-intercepts, which is where it crosses. Well, this is one where it crosses twice. So this is going to be 2 points. The first point is negative 5 comma 0. Negative 5 comma 0. And the next one is 1 comma 0. And there we go. Parabola A value. Now, once again, this is kind of weird. So, what happens is, let's say we have a beautiful, yeah, cool, that works. Just trying to make sure it's on the screen for you guys. We have 0, which would make it not a parabola. And then in between, we have negative 1 and positive 1. This area is the wide parabolas. And then out this way is the narrow. Narrow. So that's all you got to think is, okay, so assuming all problems are in this, drag and drop to match the appropriate A value. So in here, 0.5 is the closest to 0. So that means I have to move the widest one over there. Negative 4 is going to be one of the narrow ones. So there we go. That order. Yep. So let's do another one. All right. So once again, 0.25 is supposed to be the widest one. So I'm going to move this one here. Now a positive goes up and a negative goes down. All done. Yay. And finally, multi-step factoring. So this is going to be what I consider to be the hardest part of this. You have to remember to look at all three things and be like, okay, do they share anything in common? Well, in this one, I know they share a 3 in common. So my answer is going to have a 3. then a parentheses, parentheses, and parentheses. Let me change that color 3 to be green. So now I'm just going to divide everything by 3. That leaves me with x squared plus, you know what? Let me grab my calculator because calculators are awesome. 42 divided by 3 is 14x plus 13. And now we just have a normal tic-tac-toe method. So I'm going to tic-tac-toe it. And I'm going to put x squared here, a 13 here, times plus, remember, I should have chose a different color than green. 14 goes on the bottom, and the 13 and 1 multiplied to the top. So what times what equals 13, but adds up to be 14? That's easy. 1 and 13. So 1x, 13x. The Kenzie and or Mila rule, put the 2 x's there. These both have a 13 in common, so that's 1/2 of my answer, x plus 13. And the other one has a 1 in common, x plus 1. So now that I have that, I can go into Delta Math, type in x plus 1, close, open, x plus 13. Submit. And there we go. Let's do another one. All right. Oh, this is a good one. So once again, I'm going to start off the same exact way. -2 x to the 3rd power plus 26 x squared plus 60x. So I got to stop and think, okay, they're all divisible by 2. So I'm going to this time take it out with a, I guess, rainbow color. I'm going to take out a -2 just because I don't want to deal with negatives. And I'm going to take out an x, which means I'm going to divide everything by -2. -2. -2. I really got to get another color up there, I guess. All right, so that means I also got to take out an x on each one. So that means we're going to have x squared, a negative, because if I take a negative away from a positive, it's going to be a negative. Divided by 2 is 13x. And then finally a -30. You did not have to take out the negative. I just did it because it's just something that's easier for my brain to comprehend. Now I draw my tic-tac-toe table. X squared, -30, -13, -30. It's a horrible 13 down there. What times what equals 30, but adds up to be -13? I got 1 and 30, 2, 15, 3, 10, 4, no, 5, and 6. All right, so now I know we need to multiply to get to a -30, which means only one of these answers can be negative. So that counts out 3 and 10. Because, yes, if I do a -3 or a -10, it'll make a -30, but it will never add up to be a -13. So what we're actually looking at is this one. And since we want a negative, we're going to be -15 and a +2. So 2x, -15x. Mila Kenzie rule. Put the x's there. This is a -15, so x minus 15. And the other one is going to be 2, x plus 2. And now I can type it in. -2x, parentheses, x plus 2, close, open, x minus 15. Not 154. Submit. Yes. And there we go. Got the correct answer. So hopefully this all helped you. And I appreciate if you give me a like and a subscribe. So have a good day. Bye.